Let's understand eddy currents. Consider an experimental setup in which a copper plate is allowed to swing like a pendulum between the pole pieces of strong magnets. It is found that the motion is dampened or stopped soon, and in a little while the plate comes to a still position. This can be explained on the basis of electromagnetic induction. Magnetic flux associated with the plate keeps on changing as the plate moves in and out of the region between the magnetic poles. The flux change induces eddy currents in the plate. The small areas or subdivisions in the plate behave the same way as the circular loop behaves when subjected to changing flux. The current starts flowing in these small subdivisions of the plate in a circular manner like eddies in water. These currents are known as eddy currents. When eddy currents are produced in the plate, they tend to move the plate in the opposite direction as governed by the Lenz's law. That's why the plate stops oscillating after some time. Let's understand the advantages of eddy currents. Number 1. Magnetic braking in trains. Strong electromagnets are situated above the rails in some electricity-powered trains. When the electromagnets are activated, the eddy currents induced in the rails oppose the motion of the train. As there are no mechanical linkages, the braking effect is smooth. Number 2. Electromagnetic damping. Certain galvanometers have a fixed core made of non-magnetic metallic material. When the coil oscillates, the eddy currents generated in the core oppose the motion and bring the coil to rest quickly. Induction furnace. Induction furnace can be used to produce high temperatures and can be utilized to prepare alloys by melting the constituent metals. A high-frequency alternating current is passed through a coil which surrounds the metals to be melted. The eddy currents generated in the metals produce high temperatures sufficient to melt it. Number 4. Electric power meters. The shiny metal disc in the electric power meter, analog type, rotates due to the eddy currents. Electric currents are induced in the disc by magnetic fields produced by sinusoidally varying currents in a coil. We can observe the rotating shiny disc in the power meter. Concepts. Question. What are eddy currents? Answer. An eddy current is a swirling current set up in a conductor in response to a changing magnetic field. Question. Explain what happens in an induction furnace. Answer. High frequency alternating current is passed through a coil which surrounds the metals to be melted. The eddy currents generated in the metals produce high temperatures which is sufficient to melt it. Question. What is the effect of eddy currents? Answer. Eddy currents cause energy to be lost in the form of heat.